Hello, everyone. I'm really glad to be here. My name is Jan, and yeah, the presentation is about stateless Kafka brokers, also called diskless brokers. And to give you an overview of what I mean exactly, in 2020, one sec. Wait, I turned this off. Okay, cool. In 2023, a new product came to the stage, WarpStream, currently owned by Confluent. And they promised a revolution, 10x savings on Kafka costs, complete elimination of cross-AZ networking, and very lightweight stateless architecture, and solving a few issues that were present at the time. In 2023, this was a startup, more or less. In 2025, there are 6 more products in this category, so clearly the category is there. So these products are already there. Not all of them are production ready, but they are trying to carve their piece of the pie. And also, a month ago, Kafka improvement proposal was proposed to introduce a similar architecture to Apache Kafka as well. And I will be talking today about what kind of problems are they trying to solve, and how do they compare with each other regarding features, regarding architectures, what architectures are available. Because while they have a similar idea, they implement it a bit differently. So yeah, I'm here to share what I found about it with you. But before I talk about how they solve this problem, I want to outline the problem a little bit. And the problem is Kafka costs, more or less. And these charts are coming from Confluent's article about a similar topic. And they are describing the state of what it was roughly 6 years ago, where were the infrastructure costs of running Kafka. And at the time, in a benchmark that tries to represent more or less a sensible situation where we have 100 megabytes per second of writes, 300 megabytes per second of reads, we have fetch for follower disabled in this data here. This means that we still have cross-AZ traffic on the consumer side. But at the time, so roughly 6 years ago, this would be rough distribution of infrastructure costs in running a Kafka broker over Kafka cluster over 3 availability zones. And as you can see, cross-AZ networking is the vast majority. Without tiered storage, I'll explain what tiered storage is in a second. Without tiered storage, storage still remains a large part of the costs. However, once we introduce tiered storage, the networking remains the vast majority of the costs. So how does this work? We have cross-AZ networking. The issue here is the pricing model of major cloud providers, because they charge a hefty price for communication between different availability zones. And the costs, the traffic is incurred in 3 places. On the producer side, and here we, assuming we have producers in all 3 availability zones and brokers in all 3 availability zones, we will be crossing AZ boundaries 2 out of 3 times. So here we got the first situation. Second is that if we replicate this data to brokers into other AZs, we are crossing the boundaries twice. And then in 2018, we also had the consumer side traffic. However, this was more or less solved with the introduction of 2 important features. First of all, we are able to consume from the follower in the local availability zone. And if we don't have that, we can define the AZ on the consumer side and on broker side, and the default partition assigner logic will make sure that consumers are doing their best to consume from a local broker. So they are assigned the partition that's there. So on the consumer side, this is more or less solved. However, we still have producer side and replication side cross-AZ traffic. And as I said, this has been mostly solved. The charts that you have seen here, roughly a little below half of this part is the consumer side. So with like this problem eliminated, this still remains the majority of the costs. So I will be talking about tiered storage as well, because this is, to me, it's a natural progression of how to make Kafka lighter. And may I ask how many of you know what tiered storage is, or how does this work? Tiered. Oh,
it's when you need to put it to rest. Like very tired.
Thanks.
Like tiered storage. Because there's a tiers.
Yeah. So the way this works is that with Kafka, the default situation before this was introduced was that your data was stored in disks attached to your brokers, and this made the whole thing pretty heavy. And also, block storage is much more expensive than the alternative. And the alternative is that we move all of our data, except for the most recent part, into object storage, which is a regional cloud service. It's over 4 times cheaper than block storage per gigabyte. And also on top of this, in the typical Kafka highly available setup, you would replicate this data 2 or 3 times. So in total, this is why the savings on the storage side, it shrank a lot. So compared to the replication factor of 3, we would get 12x savings just on the storage side of operating a cluster. Right. So I will be talking about this progression. Right. In 2019, we had Kafka without tiered storage with still consumer-side cross-AZ traffic. And when trying to operate a highly available cluster, we would store our data in our brokers in managed disks. And this architecture is pretty rigid. It wasn't really designed to get as much as we can from clouds or cloud services. And our data was stored on the disks and also was replicated. Each replication is crossing AZ boundaries. But on top of this, the big problem of this is elasticity. Because we are when we are doing this, we are operating a data platform. We have this data, we are responsible for this data, and yet this data is attached to disks. But if we want to scale the platform up or scale up the platform down, in order to keep it balanced, we need to move this data around and redistribute it as well. So it's not possible, for example, if you are operating an application, e-commerce-like operation in one country, it's not possible to scale down for the night when we get almost no traffic. So we still pay for the compute we are running, and not only compute but also storage. That really is the bottleneck. And the issue with this, the big one, is that our compute and our storage is coupled together. So we cannot just provision as much compute as we need and as much storage as we need, because with high volume we quickly run into a bottleneck on storage. So we need to over provision a compute by a huge amount. And by the end, I'll show you a summarization of this different architecture, the benchmarks, the latency, and the costs. And also they will be available for download. So so there is a rundown by the end. So tiered storage was the first big innovation. It was first introduced by Confluent, as far as I know, and then by Red Panda. And this was the part of, you might have seen this value proposition that we are a cloud vendor, but even though we charge vendor fees, we still can save you a lot of money. And it was true, because they were storing the data in S3. And also you could keep your data for as long as you wanted. I was once in a situation where I was working on an application with little volume, but couldn't store the data for as long as I needed, which was 30 days at the time, because of the configuration of the cluster, because the organization wasn't using tiered storage, and it was a pain, because I knew that it was available at the time, it just wasn't implemented. So the value proposition of tiered storage, and by the way, if you are not using this yet, this has been declared production ready in Apache Kafka half a year ago, roughly in November. And this is a huge improvement. If you are running Kafka in the cloud and you are not using tiered storage, you will benefit greatly from introducing this. It makes your setup way more elastic, easier to operate, because you don't have to worry that much about running out of storage for a second. Also, you can save a lot of money directly on storage costs and indirectly on over-provisioned compute, elasticity, and so on. So this is the context in which WarpStream came to the stage. And they said, this is great, but we can do better by getting rid of disks completely. And on top of this, getting rid of cross-AZ networking completely. So this was a big thing. As you have seen, the cross-AZ traffic is by far the highest position in the costs of operating a cluster. And not only that, the scaling becomes extremely elastic, because we are essentially operating a stateless service that doesn't have a disk. It's just a proxy to S3 that does some logic on how to structure this data and serve it whenever consumers need it. But this is essentially a stateless service. You can deploy 20 brokers and kill 5 of them, and nothing happens, nothing hurtful to you. You don't lose data, you don't lose anything, you don't need to rebalance anything. So much simpler to operate as well. The downside is that this comes at the price of the latency. However, there are different products. I will be going through 3 products in this category that I find the most interesting. And also the downside that's impossible to ignore is that these products are new. They are not as battle tested as solutions provided by vendors, different flavors of Kafka or Apache Kafka itself. These are new products, so it's hard to avoid this. So this is where I was, I think, when I started noticing that new alternatives to WarpStream start popping up. I wanted to compare them with each other, and I did. I was curious how do they differ in architecture and features and so on. But before I talk about the differences, I'll do my best to explain what's shared among them. And what's shared is how the data flow looks like, more or less. It differs from product to product, but the general structure is very similar. So first we have the producer. This is the client that's publishing data. Whether you're producing in batches or single records, it doesn't matter that much, because there is a buffer on the broker's side that receives the data and flushes this over a certain period to the write-ahead log, or however you call these components. They call it differently. But periodically you flush the data and you produce one single file every specified period of time, be it 100 milliseconds, 250 milliseconds, or whatever. And this is happening because S3 API costs money. So you want to limit the S3 API calls, and also you want to optimize this part for write speed. And once this is persisted here, and the metadata about these batches is persisted in the coordination service, this can be served to consumers, because consumers can find this data even though it's unpartitioned, it's grouped together. This already can be served. But because this format in which it's written, it's not very optimized for consumption or long-term storage, this gets compacted in the background. Very often, not always, but very often during this compaction process, this gets rewritten from a few small files into more larger files, very often partitioned as you would normally partition a Kafka topic. Yeah, this is the data flow, but also what's shared is many features are shared between these solutions. And I've mentioned a few features that are present in more than one product. So a few products offer broker-side schema validation. Almost all of them, or all of them, have native Iceberg integration. So Iceberg is an open table format used in data lakes. Kafka is an open format used in data streaming. So you can have just one schema and stream data from one to another. Very often, these products tend to be as simple as possible, as easy for you to deploy as possible. So they often include schema registry. And this is also needed for Iceberg as well. WarpStream also includes a lightweight stream processing framework. And 2 of the products that I will be talking about support rather easy setup of a cluster that's spanning across multiple regions, which is not a great fit for Kafka, because replicating data over regions would be even more expensive than over AZs. And when you are doing this with Kafka, you are just trying to transfer the data outside of the platform itself. But here it's rather simple to do it because there is no cross-AZ traffic. And also they try to make it as easy for you to migrate to the product. So you have a ready Kafka cluster, so you just deploy on AWS Marketplace, you provision a platform, and then points in the tool, you point to your cluster, and then the data gets migrated rather easily. They want to make this as easy for you to commission their service, of course. Yeah, so while we're talking about 3 products, WarpStream is first, then Bufstream, and then AutoMQ. WarpStream was first, and they proposed a new architecture where before this, the propositions from 2 vendors that I've seen, Avon and Red Panda, was that we do, like if you want to have a managed Kafka service, so offload the simplicity, offload the complexity of managing a cluster to a service provider, you would need to grant certain permissions to your AWS account so that the control plane of the managed service would access. And WarpStream said, yeah, this is not secure enough for some of potential customers. So they proposed something else. You have a managed service, so you deploy the control plane into the vendor's cloud. However, the agents, the customer, you, deploy the agents yourself, and then the agent just registers in the control plane, and all of the information is exchanged there. And this would be a good moment to talk about how they avoid cross-AZ networking. So with Kafka, you need to write to a leader partition, right? And then the cluster takes care of replicating the data to other brokers in other AZs. In WarpStream, all agents can write to all partitions whenever you want, even if they are working in disconnected VPCs or in different regions. They can just write to S3, and if they write in parallel, then the coordination service takes care of deciding on the order of these writes. Right, so it logically orders the data in the partition, even though the writes are happening in parallel. Yeah. WarpStream also introduced a different architecture where you don't use S3 directly and write data to S3 directly, but instead write to 3 different single zone S3 buckets called S3 Express One Zone. It's a service that's available in AWS, but also I think Azure has something similar. It's object storage but local to an AZ, and this one is much faster than S3. And this approach allows them to reduce some of the latency at the price of increased cost of S3 API usage. And you see some data by the end, how much did they actually manage to cut. And the acknowledgement to the producer is sent after this has been persisted in all required buckets, and then the client knows that it can proceed further. Yeah, so this was WarpStream. I'm not going to talk about each of these products with the full the breadth of features, but yeah, I want to focus only on the main core parts of the architecture. Bufstream has a very similar approach. However, the coordinator component is not in the vendor's cloud. It's deployed to your VPC, and you are responsible for running the service. It's a self-hosted service. And the coordinator is built by default on etcd, which is a distributed metadata store. And it's using Raft as well. In Kafka uses Kraft, and etcd uses Raft. So it's like mini Kafka, you could call it. But there are different implementations of the coordination service. In one of the another one that's currently supported, but there are more in development, is Spanner. This is a proprietary service by Google that allowed them to build a multi-region service. Yeah, and their core value proposition, as far as I understand it, is with, first of all, simplicity, and second, data governance. So they support broker-side validation, but they also do some semantic validation, they call it. Confluent calls it data quality rules. So it's a feature that allows you to not only validate the schema is there, but also certain rules, like let's say this integer, it needs to be between 15 and 40. So this allows you much better control over what data actually is there in your topics. And it also supports most native Iceberg integration, because if you want the compaction process, you can write in Iceberg format directly and then serve data from this Iceberg format back to your clients if they want to read it. They also have field level role-based access control in early access, not public yet, so there is little documentation about it, but they claim it's almost ready. Yeah, so that's Bufstream. And the third product I want to talk about is AutoMQ. It's a bit different because it's a fork of Apache Kafka. What they did was they have taken Kafka and rewritten the storage layer from scratch. I will be talking about one specific setup that you can use AutoMQ in. They also provide a leaderless approach with S3 only. However, this and it differs from the others slightly, but the one that caught my attention the most is one where the write-ahead log, you don't use S3 here, so object storage and regional service, but instead you use regional block storage. So like a managed disk like EBS, but one that instead of storing 3 copies of your data in a single AZ, it stores 3 copies, one in each AZ. right? And this is a synchronous write. So you write your data here, it's there. In case of an AZ failure, your data is already present in other AZs. And block storage is has much lower latency than object storage, and also has isn't paid per request. So they can write every 1 millisecond to this write ahead lock, not every 100 to 250 milliseconds. So they actually were able to match Kafka's latency. But this is not a leaderless approach. This is a leaderful approach. So you still cross AZ boundaries, and you will see it in the benchmark because the cross AZ networking is the biggest part of the costs. And the way this regional disks work is that each broker, each partition is present in only one AZ. Data is elsewhere as well, but it's mounted to a broker that's in one AZ only. This broker writes and reads data for this partition. Consumer-side traffic is solved because you can just assign partition to a consumer in a local AZ. But on the producer side, the data is still there. But and in case of an AZ failure or maybe a broker failure, you can just spin up a new broker in a different AZ. They say that you can do it in 30 seconds more or less, so a bit slower than Kafka, way slower than the other solutions. So it depends on what's acceptable to your customer. Yeah, so this was AutoMQ. I've mentioned already, but a month ago, I even proposed introduction of KEEP 1150 to Apache Kafka. So it's coming to Kafka as well, and today they have called for a vote on the proposition. It's been under refinement for the past month. I went through the design as well, and they proposed a leaderless approach. The architecture is pretty similar to what Bufstream did. So there is a coordinator in the customer's cloud. However, this coordinator is built natively on Kafka. In the first implementation, they defined a specification for a coordinator, and the first reference implementation is based on Kafka topics. So, yeah, native similar as transactions are implemented. I've heard some concerns about limitations of this approach. Maybe the performance limitation, maybe the amount of metadata that will be transferred. But from what I've heard, the code is more or less ready. I don't know if they were using this in production or not, but they are heavily motivated to bring this to Apache Kafka because, of course, they don't want to stay behind. Yeah, so the benchmarks. Each benchmark is tailored to suit a specific scenario. So I've seen many benchmarks of vendors claiming they are 10x cheaper than Kafka. So I wanted to understand how do they differ, and like what's the gain against a more optimized Kafka setup. And yeah, so this is the definition of more or less the benchmark I tried to normalize available data to. So I used 2 benchmarks and 3 pricing calculators to collect this data. It might be off by 1,000 or 2 in different places, but this is more or less the calculation. And this is high volume, constant load scenario with 3 times as much consumption as production. And before I move on to the costs, I want to cover latency. With Apache Kafka, I found 2 benchmarks, one by Confluent, one by Panda, and the latency is very tunable, but the setup I'm talking about is 3 different availability zones and producer that waits for acknowledgement from all 3 availability zones before it considers it delivered. So P50 is, I think, the benchmark is between 16 to 20. And P99 was 403 milliseconds on average. And this wasn't a situation where the cluster was overloaded, because if it gets overloaded, the latency starts increasing. But this was this is my understanding of what properly set up Kafka with high availability, how the latency can look like if you don't tune for ultra low latency. So WarpStream with the default setup, and one disclaimer. The architecture, the stateless architecture, is very tunable and very sensitive to how much money you are willing to spend. you can decrease the frequency of writes, but then you get more S3 calls, and then you pay more. You can decrease if the client is not sensitive to latency, and then you can save some money on S3 API calls. So this latency is mostly influenced by the configuration of the test, because the setup of WarpStream and Bufstream is pretty similar, but Bufstream used 100 milliseconds in the benchmark and WarpStream 250. So having said that, the latency on WarpStream was 500 P50 and 900 P99. On Bufstream, 260 median latency and 500 P99. AutoMQ, it's not leaderless, so we can see that over half of the cost is the producer side cross-AZ networking, but because it's not leaderless and it's less optimized for cost savings, the speed of the benchmark they reported is in the same category of Kafka, which means that it's a potential drop-in replacement and more universal than this purely S3 based solutions. So this was the latency and the costs. The cost of Kafka with tire storage for this high volume setup is 240K, out of which 145 is cross-AZ networking. For Kafka with tire storage, we can decrease it in a significant manner to 175. The networking stays the same, but both storage and compute goes down. As I said, storage is the bottleneck with high volume. So if you solve the problem of heavy storage, you can use fewer instances or smaller instances because you don't you are over provisioning the compute already. WarpStream in the reported benchmark, they report this at this volume. I think the data is coming from their pricing calculator. It's 79K, and with Bufstream it was 42K. As you can see, the infrastructure costs. These are these three places. They are very similar in both solutions, right? The difference is coming primarily from vendor costs. So it's if diskless topics are coming to Apache Kafka, this would be the cost that I would expect it to generate. Yeah, and with AutoMQ, the total cost of the solution was of this benchmark. It's also an extrapolation. It's 61K roughly. So the costs really are like 3 times, 4 times lower than a pretty optimized, highly available Kafka setup. The calculations differ a little bit if you are working on Azure, because I don't know if you heard about it, but roughly a year ago, Azure changed their pricing model and eliminated all costs associated with cross-AZ networking, which changed the game completely. So if you are running Apache Kafka outside of Azure and can migrate to Azure, I would consider it, because as you can see, the networking cost is the vast majority of costs. So if we take this out, then both WarpStream and Bufstream are actually more expensive than Apache Kafka, and AutoMQ remains in the same category as Kafka if you are using tire storage. So Azure it's a very different situation. I'm a big fan of this move. I hope other vendors do it as well. We'll see how it will develop. So this was the data, and what I would like to leave you with, like how do I what conclusions do I draw from this analysis? Because I did this, I think, 2 months ago. First of all, the big thing is the drastic reduction of AZ traffic. This is the biggest position in your costs. So even if you put significant vendor fees on top of it, you can still save a lot of money if you are okay with the increased latency. The second one, and this is something that drew me through the concept of WarpStream in the beginning, because I'm coming from the background of building event-driven applications that are using Kafka. And when designing applications, like the first thing we think about is simplicity, and how resilient this is, how lightweight it is. And this is what drew me to the solution, because suddenly you can run 10 brokers, you can kill 5 of them. And also this means that you could be using spot instances, which are a few times cheaper than regular EC2 instances. So this is, everything is very lightweight. You can kill things, you can do this chaos monkey that Netflix did, and still not have as much of an impact as you would with running this full Kafka platform. And another huge thing that I find fascinating, mostly from the enthusiast perspective, is that it drives innovation. A very tangible symptom of it is the fact that Ivan publish this KEEP, and that this means that this whole movement will benefit people using Apache Kafka. But also new features like broker-side validation, the semantic validation, Iceberg integration. I'm very big on Iceberg as well, and I like the fact that everybody's doing table topic abstraction, where you can just stream your topics to Iceberg, and then it's there, and you don't have to worry that much about the pipelines that move data from one place to another. So this is my takeaway from all of this. You can save a lot of money unless you are on Azure, because if you are on Azure, then Azure saves you this money already. But to me, it's really nice that before, if you wanted to design an application building this with a team of 5 people, it wouldn't make that much sense to bring in Kafka unless you really need it, because you would probably use some more lightweight solutions like serverless SQS SNS or even AWS Kinesis or Google PubSub, whatever, right? Kafka is a data platform. To operate a data platform, it's inherently tied with significant complexity. And here, I think that this very soon will become just something like an RDS instance, right? You have a managed service, you provision it, you start using it within a day. So I really hope to see how this will impact our situation. I'm really looking forward to bringing this into Apache Kafka as well. And that's the whole thing. Thank you very much.
Do you have any questions?
I have one. You always mention AWS several times a year. What about GCP? How does the cost work?
Actually, this benchmark was run extrapolating to GCP, because the benchmark run by AutoMQ was executed on Azure, so they got the cost down to 26, and I think that the volume was exactly that. However, the cross-AZ networking, it's the same in GCP and in AWS. And in general, the price of services differs a little bit, probably, but this is pretty representative for both GCP and AWS. And for Azure, this part is the most representative.
2 questions. On which data you were working on while doing those benchmarks? And
this is the list of the sources, and the presentation will be available to in the Meetup. I also am publishing a lot and published a lot more deeper analysis on LinkedIn over the past 2 months. So each of these 3 products has a dedicated long post with tons of slides. So everything's there, and my summary is coming mostly from there.
second question, is it time agnostic?
Is it cloud agnostic? Yes, more or less. This is Kafka, so these are the instances. I'm not sure about all of the solutions in the category, but these are binaries that you deploy. Some of them are integrated well with AWS, because AWS is somehow the most, it's the biggest market, and also they have cross-AZ networking. So for example, you can provision a cluster of some of the solutions from AWS Marketplace. The Iceberg integration is natively connected to AWS S3 Tables, which is a managed Iceberg service. So it is cloud agnostic, yes. And also it is, they are working on making real life as easy as possible, so that it's also integrated with clouds as well.
Do you have any other questions? If not now, then we'll have a short break so you can grab Jan and ask them. Thank you, Jan. It was great talk. And now,
Thanks a lot.